Okay, recall from last time we had ui equaled ei and I had separated that plus some gamma I. Gamma is actually going to be our omitted variable bias, and I want you to understand it as something that we cannot directly mathematically test for. So OLS, ordinary least squares, will come back with no bias indicators, but we could still have a gamma I, and that will make sense when I explain it here in a minute. That being said, want to just focus right back in on being left with EI then. So in a case of unbiasedness, if we take this, which is one individual's observation, and we generalize it to the population, this would become beta naught plus beta 1 x plus, and this would go to 0. And why is that? Because we'd say if we took the expectation of ui, where ui only equaled ei, because we're setting gamma equal to 0, given any xi, that equaled 0. And when we take an expectation, that gives us a general population formula. And so this would be that expression, is a general population formula. And so we would remain with that. Now with that being said, and now you can kind of see some of what we've been working on, let's say that gamma I is not equal to 0. That would be a problem. But it would be a problem that we cannot observe again through regression. And here's why. Let's return to our example. And say we've got yi right now. This is just an individual observation we'll start with. Plus beta naught plus beta 1 xi plus some ui. If there's a gamma I, so in econometrics we ignore the ei. We know that'll go to 0, so we don't worry about that anymore. I pointed out so you know exactly what gamma I is not equal to. But if we have some gamma I, we could think about it in the context of this example. So yi was our wage, essentially, the wage observation of an individual. Now and then xi was going to be the level of education of that individual. And let's generalize this. Let's just say y equals now beta naught plus beta 1 x plus u. There might be a problem if u doesn't, well, there is a problem. We have bias if u wasn't equal to 0 in the general population sense. That is, if those terms don't cancel out. And that will occur because u would have something that actually would covary with our x term. But in a sense that, not in the EI sense, so not in something we can directly observe. And I know this seems weird. But suppose, so we keep talking about education. We keep talking about wages. Now, if we talk about u, and we're saying, no, in fact, there is some underlying covariance between x and u, such that the covariance does not equal 0 because of some unseen gamma factor, what is it? Well, let's say we have something like ability. And then ability covaries with education, and education with wages. Now, this would make sense. So, when I would say ability, I want you to think of innate ability. So as we move forward with this example, think of it in terms like how you would think of computer hardware. So this would be a good analogy. So it's something that you're basically born with that you cannot change. Some people are just smarter than others. Some people are quicker than others, that sort of thing. And so ability is innate. It is not. I also want to emphasize the direction of the relationship. Education does not affect ability. Ability only affects education. And so just like computer hardware, we would say the better hardware that you have, so if you have like a fancy graphics card, you could play some pretty sophisticated video games. But if you don't have a fancy graphic card and you have a computer from 1999, you're not going to be playing Cyberpunk 2077 on a computer that was built in 1999. So the idea is, too, that the hardware would be a prerequisite for the software. So you can think of ability as hardware, education as software. And you could also think as this as, to sort of isolate the concept that there was no software on the planet that I could upload to a 1999 computer that would make it run a game that's, you know, designed for more of the modern systems. And so, you know, you wouldn't run Cyberpunk 2077 on max graphics just because you installed some other software on a 1999 tower. That will not work. And so it doesn't feed back the other way. So that's the first thing I want to emphasize. Second thing I want to emphasize is we get omitted variable bias not only if ability affects education and it affects wages, but ability has to do two things. So it has to both affect wages, but it also, education, but it also has to directly affect wages. The reason being is, and let's use Ava as an example. So if we have Ava and we know she made $51,000 a year, which pathway do we say was the cause of that? So it could be the case that Ava has 12 years of education and that accounted for $42K of her earnings. And then the rest of her earnings, this ability factor, was the remainder of say, $9K. And so it could be that, but we don't know. We don't really have a way of telling. And so this is the problem is or we could have somebody really smart, you know, and with more education, say, earning $100,000 a year, and same thing would apply. But we would say if ability both affects our education attainment, so think about that for a second. Ability determines, if you have higher ability, generally you will, for pools of individuals with higher ability, generally they will have higher levels of education. So ability sort of being a prerequisite for, if you had a PhD in mechanical engineering, you would need a lot of innate ability before you could even get that education. And so the mean value of, say, someone with that level of education, if we were to do some metric of fixed ability like IQ, would probably be a standard deviation or two higher than the mean value of the population that we observe, the general population. And so that is to say that there will be some correlation and ability will determine some education. So it feeds through the education pipe into wages. Then there's also this sense in which that same ability can directly translate to on-the-job performance. They learn tasks quicker. They're able to adapt in their environment quicker to certain things that they need to be able to adapt to. So the problem is, if we have a regression that's only looking at education, but education also is fed by ability, and ability also directly feeds into wages, and then it also feeds through education into wages, we don't know, the issue is we don't know what to ascribe to what. And so the problem becomes it's saying, okay, well, there's some individuals, you could think about it this way, like again, Ava, where, let's say Ava, now she went through college and all that, where she's earning a certain wage, 100K a year now. We don't know, without some separation of these terms, we don't know, if we're just modeling education, what aspects of that 100K were education and what were actually ability. That is to say, omitted variable bias in this exact case is causing us to overcount. And so recall when I had said that we had this function y equals 1.3x plus 28.2. Suppose that the real relationship, because of ability, is actually 0.9x1. We'll call that the education term. And then we add to that 0.4x2, and then our intercept of 28.2. I'm just using this as a loose example, but in reality, education should be separated from ability, and ability actually would account for 0.4 of the 1.3 we observe when we don't also run our regression considering ability. Because if we don't consider ability, all of that ability information that could potentially be causally related with wages, where, say again, like, like say 20K of this was actually ability, then, and let's say she got less education, but the 20K was just this sort of like, again, ability parameter of hers that gets fed through the pipe because she correlates with education. And so it's this idea that she's very able, she gets a good degree, she makes 100K a year, but part of it isn't the education. Part of it, she would earn that 20K a year even if she didn't have the education. That's the big important point. And so we're overcounting, and so it's actually only 80K a year that was, or part of the 80K a year that was caused by the level of education that she had plus some intercept. And so that's where this breakdown is coming from. So hopefully that's starting to make sense or set in what this idea of omitted variable bias is. And so there's a few conditions, again, to reiterate. So one, it has to both covary with the independent variable. It has to be upstream of that independent variable. So that's a second kind of precondition. You can't have feedback the other way. And then third, it has to also have some sort of causal relationship with the dependent variable. In this case, that was wages. If it didn't, consider then if it was the case, a weird case where ability didn't affect wages at all. Well, but it affected education, then, so it didn't affect wages directly, but it affected education. I know this is kind of a weird thing, but if it only did this, this actually wouldn't be a problem. Then we basically would just say education is a function of ability. So it's something's dependent variable, but as long as this doesn't also feed into something that we think education is an independent variable towards, and so ability only affects education, again, this wouldn't be an issue. And so it's kind of a weird thought experiment because, yeah, in reality that wouldn't happen, but that has to be a condition, is that ability also has to affect the dependent variable, the final dependent variable of concern. Otherwise, it just kind of becomes its own regression. And same thing too, even weirder, would be like saying, oh, ability only affected wages and didn't actually affect education. And so if it did not go through education and it only affected wages, that's not a problem for us. So this was something that when I was in undergrad, I would get confused about in omitted variable bias. I always thought that it was just, oh, we're lacking detail, we need more parameters. And so I thought, okay, well, the best regressions, we just throw 800 parameters in there and then we call it good because we know what every parameter is doing related to the thing we're concerned about. But that's not what this is saying. What this is saying is, no, we don't need to be worried about parameters that are totally unrelated to education. So maybe it's not ability, maybe it's like networking or something, like business networking, where it's just literally, you maybe you grow up in a well-to-do family and they know people from your well-to-do neighborhood, and so you have those connections, and that has nothing to do with education. We don't care about that if we're trying to create a regression about education. The key point of a regression with relation to education, or the key question that we're asking is, what is education's effect on wages? The only thing we need to account for is things that double feed. So things that can run through the education pipe and run around it at the same time into wages, because then we need to separate, okay, how much credit actually goes to education and how much credit actually goes to, in our case, ability. That's the big takeaway with these. So that's this idea where gamma becomes a more problematic concept, or a non-zero concept, and it's this hidden term. And what's interesting, again, is ordinary least squares won't mathematically pick up on this. It's only designed to test basically return a line of best fit, and if you mess it up, then repairing the line of best fit doesn't tell you if the slope itself, this 1.3x, it tells you that 1.3x, as we saw, was good, but it doesn't tell you anything about if there is underlying information that's being carried along with that. So you could think of this 1.3x as carrying the ability bucket along with it, where in fact maybe we have 0.4x of that 1.3x is just hidden ability that's being pulled along because ability varies with education. The more ability you have, generally the more education those individuals have per those buckets. And so that's the major point here. Now I want to play with some stuff here real quick on this. So let me jump on my notes. So, that is to say, we could say, in this case, you'll see it in a textbook saying covariance of x and u does not equal 0. Do not take that to mean that you can test the covariance of x and u, because mathematically, you will always get this equal to 0 if you have done your ordinary least squares correctly. Even if there is bias, that can occur. So I cannot stress that enough. And I know it seems weird. It's probably the weirdest part of econometrics. Probably, honestly, conceptually, the hardest part of it. Once we're past this, it's pretty downhill from there, in my opinion. But now, what do we want to say the gamma term actually means? So I'm gonna do a little mathematical manipulation here now with what we had. So yi equals, then we have this idea of beta naught plus beta 1 x1. And I'll do this in general, not in I form, I'm sorry. So plus beta 1 x1 plus beta 2 x2. I want to add this plus some error term. And actually we could add the I subscripts. So in reality, our true function should look something like this. Now, this x2 term equals something. The x2i term equals something. And we could even attach the beta 2 to both sides. We would say it's going to be its own function. So this is ability. And then beta 2 is basically the wage coefficient of ability. But if it co-varies with education, this is the concerning part, is alpha 1, x1, so it's plus alpha 1, x1, and then we could say x1i. And then finally, we add some sort of like error term here, or basically just some VI is basically it's not necessarily an error term, it's a random term. So when we multiply this out, we would get, this would be beta 2 alpha naught plus beta 2 alpha 1 x1i plus beta 2 VI. And you can think of this beta 2 VI term as basically VI being some sort of causal ability variable. So like higher VI means you have more ability, lower VI, less ability. But it's aspects of ability that are totally detached from education. So maybe this is like a sports ability, like you're just really good at sports, and so you are a high-paid individual. But we don't necessarily care about this term, and I'll lean into that here in a second. And so this more broadly then, because this equals this, we're going to say then our yi equals beta naught plus, actually I need to come over, don't I? Need more room. So then we would say our yi equals beta naught plus beta 1 xi, beta 1 x1i, plus, this is now our beta 2 x2i broken apart. And then we can return here and say ui, where ui would just equal ei. That's basically the leftover mess. Because now we've accounted for ability. Now we're bringing it back into the model so we don't have an issue with it. So when we look at this, now if we want to start simplifying some terms, there's this idea of beta 2 alpha naught is just some intercept. So if we take beta naught plus beta 2 alpha naught, that'll just return for us some new beta naught. You could call it beta naught or beta naught n. We could call it bond, but beta naught n meaning new. It will be subsumed under that term. Now, for those of you really thinking deeply about this, you'll go, well, wouldn't that intercept be biased? And yeah, it kind of would, but the real crux of econometrics, we don't worry about the intercepts. The question is for incremental changes. So calculus familiar students who get this, if you take the derivative with respect to x1i out of the function, what do you end up with? That's what we're worried about, is how does a variation in education cause a variation in wages? And so that's what we're trying to isolate with all of this stuff. And so that's how I want you guys to think about this, is more along those lines of saying, okay, yeah, this would cause some sort of, this doesn't cause anything in the variation, it just causes where we actually, intercept. So it's actually not a big deal. It's something economists don't worry about because it's irrelevant to our question. And so we just say beta naught n for these terms. We'll put this yi over here. And now we have, I want to come over here. So we've got this idea of beta 2 vi, and that actually will get subsumed into the ui term. So plus ei just returns some other random error term. Because what we're saying here is, if there is not an x1i attached to this, then this becomes sort of a constant relationship in relation to education. It's its own thing, which means we can randomize with it. It doesn't relate to this. Again, you can think of it as like sports ability. It's like, or something like that. Like your formal public school education, if you don't take and exclude gym class or any of those or like extracurriculars, no matter how much math you take, you're probably not any better at basketball in reality. And so that's what this is saying, is some people are better at basketball, and so they get really high wages. And some people are really bad at driving, and so they get lower wages. And so that gets subsumed under the UI term. So we can kind of erase that out. So we'll leave that here, plus UI now. So, and you can think of it also as UI new. So we're not concerned with that. Again, that sort of becomes a non-issue for us. And then finally, we are left with a couple of things. And actually, we got to move this a little further forward. So this drops down. So obviously, we are still concerned with beta 1 x1i. But then we also have beta 2 alpha 1 x1i. This alpha 1 x1i portion is basically saying how much of the education information is impacted by our ability, is impacted by our ability. And so this is saying, okay, how much of our, of what we're doing with education is just fed by ability. But then when we attach this beta 2 term, it's saying such that it's separately affecting our wages. So it's allowing us to say, okay, yes, this moves with education. This is the amount of ability that moves with education, but it's not education itself. It's actually the ability itself that's feeding into the wages. Hopefully that makes sense. So we isolate that term, and then we have that UI, which had subsumed that other term. And so we're left with this formula, and we could break it down and just simply then call this what we're left with here, still the remaining x2i, beta 2, plus beta 1 x1i, plus beta naught, we'll just simplify that term, plus ui. So now all we're saying is, okay, we've actually separated the ability term such that we can isolate education and say something meaningful about education's relationship with with the predicted wage of said individual. And if we de-individualize this is why I kind of want to return to the I's. If we just now break this back down, well, knowing that UI is basically still just equivalent to something akin to EI, again, plus some other thing that doesn't vary, and therefore randomly, if it's truly random, it will cancel out to 0. This general population function would just be beta naught plus beta 1 x1 plus beta 2 x2. And then we drop the UI term. So this becomes sort of our average term, but it's now an unbiased term. Last thing I want to return to before I finish this out, and sorry this felt a little shaky. It's a long video. It's dense. It's a lot of material. Of course, the textbooks all gloss over us on this information. But the last thing I want to then touch on is, again, then this idea of the expectation of UI given xi, but supposing that this does not equal 0. This is more of a theoretical construct, again, than something we can test for the exact same reason. But if you think about it, our expectation, normally it would be centered at 0, at some zeroed value. But in reality, yeah, if we have some sort of bias, what this is telling us is that the error term is off-center, say by 1 or whatever. I'm just choosing an arbitrary value. But what that's telling us is when this doesn't equal 0, our slope we're basically, or not telling us, it's what it's saying is that our slope is containing more information than it should. That can be positive or negative. The slope could be smaller than it needs to be because there's some sort of negative relationship going on, negative correlation with another term that applies to all of this stuff. And so that's sort of the big takeaway. Again, I want you just, when you see this, when it does not equal 0 or the covariance of x and u, I don't want you, and that does not equal 0. I keep kind of emphasizing these because I don't want you guys to think like, oh, though that's just something we can mathematically test for or fix or whatever. This is really just a statement about some underlying information that we're missing from the model, and so that's the major takeaway. But with that, thanks for sticking with me through the error series and leading up to omitted variable bias. And with that said, I will see you guys next time.